Hi Year 12s. Today we will look at a specific type of continuous distribution, the normal distribution. The normal distribution is in the shape of a bell curve and is a commonly occurring probability distribution in nature and is a close approximation for the measurement of variables. Let's now take a look at the normal probability density function. It is given by the equation f of x equals 1 over the square root of 2 pi times e to the power of negative x squared over 2. The bell curve has the following key properties. It is symmetrical around the y-axis, the mean of the function is 0, and the standard deviation is 1. It is possible to translate the graph by shifting to a new mean, by minusing the mean from x. It is also possible to provide a dilation factor to change the spread of the normal distribution by dividing our new x term by the standard deviation and multiplying the y term by the standard deviation. This gives us a new equation of 1 over sigma times the square root of 2 pi times e to the power of negative a half of x minus mu over sigma all squared, where sigma is our standard deviation and mu is the mean value. The main strength of the normal distribution is that we know what percentage of the distribution lies within each standard deviation of the mean. About 68% of the values are within one standard deviation of the mean. About 95% of the values are within 2 standard deviations of the mean. And about 99.7% of the values are within 3 standard deviations of the mean. To help us solve the general normal distribution, we can apply the general normal distribution to our original normal distribution. This we can do by linking our z value, which is a standardised value, to our x value by minusing the mean and dividing all by sigma. When n is positive, the value lies above the mean, and when n is negative, the value lies below the mean. The z value can be thought of as the point on the original normal curve that incorporates the same amount of the distribution as the x point on the general normal curve. Let's take a look at question 5 from the 2010 Exam 1. If we first look at part A, the answer is not that hard to find. We need to find the probability that x is greater than 5 for a normally distributed random variable with a mean of 5. Given that normal distributions are symmetrical, we know that 50% of the distribution lies on either side of the mean. Therefore, the probability that we get a response greater than 5 is 0.5. Part B asks us to find the equivalent standardised value for the probability x is greater than 7, but at the other end of the distribution, for when the standardised value is less than b. First, we find the value of z that corresponds to the probability where x is greater than 7. So we use the formula z equals x minus mu all over sigma. X here is 7, the mean is 5, and sigma is the square root of the variance, which is 3, giving us 2 over 3. Given that the normal distribution is symmetrical around 0, the probability that z is less than b is the same as the probability that z is greater than negative b. Therefore, if we times our z value of 2/3 by negative 1, we will get our b value and our answer. The symmetrical properties of the normal distribution are key to answering many of the normal distribution questions. Trying to get your head around this will make these questions much easier. Happy studying!